Why is Python isinstance transitive with base classes and intransitive with metaclasses? I am new to metaclasses, and may be using them in unintended ways. I'm puzzled by the fact that the isinstance method appears to have transitive behavior when dealing with subclasses, but not when dealing with metaclasses. In the first case, implies that isinstantic x is true for x equal to a, b or c. On the other hand, here is a metaclass example. Yields. That is my class is an instance of the metadata element metaclass, and my underscore instance is an instance of the myClass class but not of metadata element. Is my interpretation correct? Is there a simple explanation for this?
The confusion there is that myClass is not an instance of data element base. It is an instance of the metaclass, metadata element, and an instance of all superclasses of that metaclass, that is, type and object. Just like what happens with instances of ordinary classes. Pasting your snippet in the interactive interpreter I can do. The relationship of data element base towards myClass is of superclass. So, if you ask if it is a subclass of data element base, you get true. The class bases are passed as the third argument on the call to type._new_. So, in other words, a metaclass is the class used to build a class, and it has nothing to do with the inheritance chain of the created class. And conversely, a given object will always be an instance of any superclass of its class. The metaclass is not a superclass of its class. Once you understand that, you will notice that the behavior of isinstance and issued class is the same across non-metaclasses and its instances, and metaclasses and the classes created through them. On an unrelated notice, although your code worked the way it is not encouraged. The signature for a metaclass_new_ method should be conformant to the signature of type._new_ and receive the metaclass itself, name, bases, namespace and optional keyword parameters. The way you wrote it, departing your metaclass from this signature forces your code to declare classes the way you did, by explicitly instantiating the metaclass with a call. It can't be used as a metaclass that will create a new class from a class statement and its body, as in this case, Python calls the metaclass with the parameters used by type._new_.
The basic purpose of isinstance is to check whether an interface is available from an object. The interface of an object of type, data element base, for example, might include that it has a value attribute. Indeed, my_instance.value is 4.55. The interface of an object of type, metadata element is that it is a class that, among other things, inherits from data element base. Is my_instance such a class? No, it's not even callable like classes are. It is an object of such a class, but isinstance my_interface, metadata element, would imply that it is such a class.